Hello, this is introduction to limits. So I have a limit of f at x as x approaches a, which is l, which is equal to l. So what this means? This means on your x-axis here, let's say this is your x-axis and that your y-axis. If you are moving along your x-axis, like if you are moving along your x-axis, it's either from this side or that side. If you have a point that is stationary here, that is fixed, that are not moving. So if you have a function of f at x, like I did a function of f, so what will be the value that you will get as you are coming closer to this point on your x-axis, which is a, which value of f that you will be approaching as you approaching a on x-axis? What is the value that will approach on y-axis, which will be the value of f? So as I'm coming closer to a, let's say on this one I will have a value that will be here, and as I'm coming closer to my a, I will have the value that will be here as I'm coming closer. If you notice by those 2 points, that I indicated, by those 3 points that I indicated, if you see I'm getting closer to L, I'm getting close to L. And if I'm here close to A, I will be more closer to L. So let's say our L, let's say by the time I'm hitting A, I will be on L exactly. So this what this means. What will be the values that we get of f as you are getting closer to A? What will be the values of f that you get as you're getting closer to A? So this is what the limit means. Even if we can come from this side, you'll see, you'll notice as you're coming from this side, we'll have the values that will be like this. If you see those values are getting closer to L here. So this is what meant by a limit. So let's see an example. So we can present a limit using graph, and we can present a limit using which is called a tabular form and a direct substitution. So let's start with the tabular form of this example, which is a limit of x plus 2 as x approaches 1. What will be the value of this limit? So I will have to use a tabular form. So when I'm using a tabular form, we have something which will be like this one. So I will have my x plus 2 here, and I have my x values here. So I will have to use the values that are close to 1, which is I'll start from left to right. So from left to right, I can say 0, this is 0, 9, and let's go closer and closer to 1, 0,91. And so let's approach our 1 from right to left. Now I will have something like 1, 0, 1, 1, 0, 1, like this. So what are the values of x plus 2? What are the values that I will get if I'm putting those values that are close to 1 to that function, which is x plus 2? So if I'm placing x with 0, 0,9, I will have 2, 9 here, and if I'm placing 0, 0,99, I will have 2, 99, and if I'm placing 1, 0, 0, 1, I will have 3, 0, 1, 1, because it will be 1, 0, 1 plus 2, plus 2. And if I'm saying here, I will have 0, 1 like that. So what do you notice here? As I'm from, let's say, from this side to from left, this side it's right. So if I'm coming from left down there and I'm coming from right here, there is a value that I'm compressing here, which is 1. So those are the values that are close to 1. So if I'm substituting those values to that function that are close to 1, what is output that I'm getting here? So if you see, let me take another card. If you see, if I'm going from, you see in this case now it is our left and no, still, yeah, it's our left and our right. So if I'm going from left and going closer to, yes, I'm going from left and to right here, and I'm moving from right to left here. So if you see, I first get 2,9, and then I get 2,99. This means that I'm coming closer. I'll get 2,9999, 2,9999, 2,99999 until I get to 3 that will be inside here. And if I'm going from right to left, I'll have 3,001, then 3,001, 3,00001 until I get to 3. So I can then conclude this limit as the limit of x plus 2 as I'm approaching 1 on my x-axis will be 3. So by use of this table, I can then conclude by the use of this table. But there is another form which is called a direct substitution, whereby you can have your limit, whereby you have a limit as x approaches, let's say a, as x approaches a here of f at x. So what you do in order to get a value of this limit, you have to do a direct substitution. Directly substitute x here. So we'll have this. We'll have the limit of f at x as x approaches a equal to f at a. So let's apply this on this example. So we'll have a limit of x plus 2 as x approaches 1. So let's directly substitute our 1 in place of x. So we'll have 1 plus 2, and this is 3, which is the same as the one that we get when we are using our table. So if you see there is a direct substitution and a tabular form, you can use them to evaluate your limit. So let's see another example. Here I have another example, which is a limit of x squared minus 4 divided by x minus 2 as x approaches 2. So let's try to apply our direct substitution and see what will happen here. So it will be x squared minus 4 divided by x minus 2. So if you say no, it's 2 minus x, 2 minus x. So this will give us, so 2 squared is 4. So 4 minus 4, this will be 0, and 2 minus 2, this will be 0. So we will end up dividing with 0. So any number divided by 0, that's undefined, the value that we don't know. So what we can do in order to evaluate this limit? So if you see any part that you can factorize, or you can simplify, or you can get a common factor, please do so. So here we have a difference of 2 squares. So if I can come here, I can say my limit as x approaches 2, I will have 2 parentheses to factorize a difference of 2 squares. So the factors of x squared is x and x. The factors of 4 is 2 and 2. So they have to be positive and negative, so that when you multiply them, you get this negative sign here. And then I will divide with my x minus 2 here. So if you see now, this x minus 2 will cancel out with this x minus 2. So what I will left with, I will left with a limit as x approaches 2 of x plus 2, and this will, and then we can apply a direct substitution, because we will be no longer dividing with 0. So our function now is divided by 1, which is defined. So we can then direct substitute our 2 in place of x, and we get 2 plus 2, and this will give us 4. So this will be the answer for this limit. This limit will be equal to 4. So that was it, guys. I use a tabular form and direct substitution to evaluate a limit. On the next video I will be doing like some more complicated example, like the one with the roots and the cubic ones, the fractions ones, so that you can get more familiar with the limit. Thank you for watching my video. Please don't forget to subscribe, like, and comment to my channel. Thank you for watching my video.